Since the ball moves with the speed of the mass of the ball of 0.75 kg, move with the speed of 3 meters per second, and then stop dead on a wall. We now calculate the impulse Ft. From the formula of momentum, Ft is equal to mv. Ft there is the impulse, is equal to mv, mass times velocity. Therefore, the impulse is equal to 3 times 0.75, which will give us 2.25 Newton seconds. Or since the body stop on the wall, which has a final velocity of 0, we can still say that we can take the direction of force to be negative. Ft is equal to mv minus mu. So since the final velocity is negative and the body is moving stopped, since the body is negative and the body is stopped in the opposite direction to the wall, which now become negative velocity of 3 times 0.7, which gives us plus 2.25 Newton seconds. Example 17. A spacecraft of mass 450 kg is moving in a space with speed of 3 times 10 raised to power 3 meters per second. A rocket is fired straight ahead, emitting 1.5 kg of gas at a speed of 2 times 10 raised to power 4 meters per second. Ignoring a slight reduction in mass of the aircraft, find the change in its speed. Solution. Since the mass of the rocket is 450 kg, moving with a speed of 3000 meters per second, and another rocket from the rocket is fired 1.5 mass of object with a speed of 2 times 10 raised to power 4 meters per second. The weight of the rocket will reduce to 448.5 kg. We are asked to find the common velocity of the rocket. Giving positive to the direction of force, momentum before collision or emission is equal to momentum after emission. 3000 times 450 minus, since we have already taken the direction to be negative, all the directions to be negative, will be negative 3 times 10 raised to power 4 times, which is equals to minus 448.5 V. After adding the multiplication, we have 1,350,000 minus 30,000, which is equal to minus 448.5 velocity. Then, making our subtraction, we have 1,320,000 is equal to minus 448.5 velocity. Making velocity the subject of the formula, we have our velocity to be 200,943.4. Ignoring their masses, you still have that minus, since the bracket we have taken all their direction to be negative, minus 3,000 times 450 minus, that is 1.5 times 2 times 10 raised to power 4 will give us 3 times 10 raised to power 4, which equals to minus 4 250 volts velocity. Then doing our multiplication, we have 1,350,000 minus 30,000, which is equals to 450 velocity. Then doing our subtraction, we have 1,320,000 is equals to 450 velocity. Making our velocity the subject of the formula, we have that the velocity will now be 2,933.33 meters per second. Example 8. Find the momentum of the body in which of the following: A. Mass 2 kg, velocity 0.5 meters per second. B. Mass 80 kg, velocity 15 meters per second. C. Mass 30 kg, velocity 72 km per hour. Solution: A. Momentum is equals to mass times velocity. Our mass is 2 and our velocity is 0.5. If we multiply the two, we get 1 Newton seconds. B. Momentum is mass times velocity. The mass is in gram. To convert it to kilogram, we divide it by 1000 to give us 0.08 kilogram. Then momentum m is equals to mass 0.08 times velocity 15, which give us 1.2 Newton seconds. C. Momentum is equals to mass times velocity, and mass is equals to 30 kg, but the velocity is in kilometer per hour. To convert it to meters per second, we times 72 by 1000 and divide by 60 times 60, that is 60 minutes and 60 seconds, to give us 20 minutes meters per second. Then our momentum is now equal to mass times velocity. Our mass is 30 times, but our velocity is 20, which give us 600 Newton seconds. Example 19. A trolley railway track, mass is 0.3 kg, traveling at 2 meters per second, collide with another stationary truck, mass of 0.25 kg, and they couple together. Find the common speed after impact and the impulse between them. Solution: we have that the mass of the train is 0.3 kg, moving at a speed of 2 meters per second, and it collides with a stationary train of mass 0.25, and two of them we now get a common velocity of 1.09 meters per second. Do you think you can pause and see if you can get this as the common velocity? If not, okay, let's show you how. Giving positive to the direction of force, m1 v1, that is mass of the moving train plus times velocity of the moving train plus mass of the stationary train times velocity of the stationary train is equals to mass of the sum of mass of the two trains combined together times their common velocity. Then we substitute the value. We have that the mass of the moving train is 2, and that its velocity is 2 meters per second, plus the mass of the stationary body is 0.25, and the velocity is 0, which will now give us the mass of the two objects is 0.55. Then we make our multiplications and additions. We get 0.6 equal to 0.55 velocity. Then if